So, hello everyone, myself Rishi, and today we are going to learn about a new software named as Cadence. So, firstly, for opening Cadence, we are going to terminal and run a command virtuoso and this will open our workspace where we are going to create libraries and cell views. So, firstly, we go to File, go to New Library. Let's name our new library as ABC and attach to a existing technology library. Wait, ABC already exists, ABC1. We are going to attach it to GPDK90. This means we are going to work on 90 nanometer technology. So we are successfully created the library. Now we are going to create a new view. For this, we are going to new cell view and select our library as ABC1. Now we are going to study about inverter and its characterization. So we name it as inverter. So this open up a workspace where we are going to create many circuits. So firstly, we will go to create, then instance, then browse. Now we are going to take things from 90 nanometer technology. So we are going to GPDK 90 and NMOS. So firstly, are going to take the symbol of NMOS. Then now again create instance. Now we need PMOS. PMOS. Also, we can change its property by pressing Q on by going onto the device. Now here we can see its head length, width, and all the other specification that MOSFET has. Now we can alter this specification and check for new upgrades in our circuits. Now firstly we will resize this. Now I need pins that will be in VDD. Let's just take VDD in as input pin and another pin as output pin that will be V out. Now we are going to connect all these things with the use of wire, and for using wire we will press W on our keyboard. Now W. Also we need to short the substrate and body and source as we don't need some body effect in our circuit. Now for V out. Now we are adding some pulses and VDD for making our circuit work. So that will be in our analog library. So VDC, and we also need V pulse, and more importantly, we need our ground, ground 1, ground 2, and ground 3. Now again, we are going to connect all these circuits by pressing W. Now we also need to change some specification of V pulse and VDD. So for that, we are going to go onto the device and press Q. Now the specification we firstly need voltage 1 at 0, voltage 2 at 1.8 volt, 1.8 volt. Then we have our period as 20 nanoseconds, 20 nanosecond, delay as 0 seconds, rise time is 1 nanosecond, fall time is also 1 nanosecond, and pulse width will be L 10 nanoseconds. So we will apply, then press OK. And also for VDC, we need DC voltage as 1.8 volt. apply. Okay. So we have VDD, V pulse, and ground connected on. Now we are going to analyze the circuit by pressing launch, then ADEL. Here we are going to firstly add the analysis we are going to do, the transient analysis, DC analysis, AC analysis. So firstly we are here doing transient analysis with 200 nanosecond, moderate, apply, okay. The second analysis we are going to do is DC analysis. Component parameter, we are selecting component V pulse. Okay. And start will be 0 and stop will be 1.8 volt because we have given VDD 1.8 volt. Apply. Okay. Again, we are going to go to outputs to check the axis, the outputs we need on our graph, like the input on x-axis and the output on y-axis. All that things we will be selecting from here onwards. Now for that, we are going to edit from schematic and V in and V out. Then apply. Okay. Again on to the analysis window. We have V in, V out, transient analysis, DC analysis. So for launching this, we are going to run from here, netlist and run, or also you can go to simulation and netlist and run. So here we are going to get the output results. So here, as you can see, let's split the window into two. So as you can see, we have V in and inverted to that, we have V out. Also, you can see in DC response also, whenever V in is growing, V out is decreasing. Then when V in tends to 1, the V out tends to 0. So here how can so here is this how we can do the analysis using Cadence Virtuoso. Also, you can make various designs and circuits in this and do the transient and DC analysis and any type of analysis for making it run. Thank you very much.